Okay, good evening. My name is Candan. We are going to cover tunneling and bypassing next generation firewalls. So we will give you an idea to how to bypass a firewall and also transfer data on closed port also. As you know, my name is Candan. I'm the CTO and the co-founder of NormShield. I'm senior penetration tester and also the application developer. So I like to both develop and exploit those kind of things. This is my email address and my Twitter address. So I usually prefer to announce something on my Twitter accounts or our company Twitter account. So if you subscribe that or if you follow that, it will be useful for you. For example, the videos that I recorded in the last meetup, I already mentioned in my Twitter accounts. And also I tried to send you an email. I don't know whether you all guys have those emails. So the outline, first of all, we are going to start with the basics and key terms. Then we will continue with the basic protocol tunnelings, and we will use the ICMP tunneling. We will run a demo for that. And then we will use DNS tunneling and explain how it works. And we will demo a DNS tunneling, and then we will use a malware to run a DNS tunnel capability. Then we will continue with a little bit Tor explanation. So if you use a custom Tor configuration with the proper settings, it will help you to bypass firewalls, although the Tor is not available, allowed in the network. So if we have time, we will talk about the countermeasures, and also the promiscuous mode tunneling means that we can transfer data on a closed port also. So that's called promiscuous mode. We will talk about that, and let's go start. Okay, so this is the general structure. Let me use my cursor. Can you see the cursor? Okay, good. So this is going to be our Kali Linux. In theory, we are going to communicate with internet, and we need a server that translates our packages to normal packages. So we are going to send some of the VPN packages, some of SSH packages, or SUX proxy, or even HTTP, or even we can use the DNS packages to transfer our data to the server, and then the server is going to transfer our data to internet. So the first thing is, if you're talking about tunneling, tunneling occurs only between client and server. You can't tunnel to Google directly, okay? There is no way to do that. And maybe there is a way, but it's not exist yet. So the thing is that in all tunneling examples, we are going to show you a client and also show you a server, okay? That's the basic. You have to have a server to translate your packages to a normal internet package. So in basics, in an IP package consists of multiple layers, right? OSI layers, and the layer 2, you see the Ethernet packages, it's 28 bytes. It's defined in RFC 894. And layer 3, it's an IP package. IP definition at 20 bytes is allocated for this space. It includes the IP protocol name, your source IP, your destination IP, things like that. And also layer 4, there are 20 to 60 bytes allocated for that, in which you can define which TCP protocol you are going to use, which ports you are going to use, and what's the data segment size, things like that goes into this segment. And in the layer 7, you are going to look at the actual data segments, right? So as you can see, in the MAC is actually attached to an IP header, it's attached to a TCP UDP, and it's attached to a layer 7 data segment. So in Wireshark, it looks like this, but we can open the Wireshark and take a look at by ourselves. Let me see if I can open another Wireshark. Okay, that's not possible. All right, let's start and what is this sniffing? Okay, yeah, let me snip my wireless, and let's open an HTTP web page. Right.com. Okay, so we already have the HTTP traffic here. Let's quickly filter that. So Wireshark allows you to filter with a protocol level. So this package is actually a GET package. It's an HTTP. And when we drill down this package, let me open it in a big window. So as you can see, this is the layer 2 package, layer 2 segments. Pardon me, this is layer 1, 1 and zeros. This is layer 2. And layer 3, it says that, hey, this is an IP protocol version 4, and the source IP is 10 dot something, and the destination is going to be this one. So time to leave is going to be this. So these are the IP headers included in, and then the layer 4 includes the TCP UDP definitions. As you can see, this is the source port, is my random port, is 58,000 something, and the destination port is going to be, hello Fletcher, let me have you close to here. Okay, so Fletcher is going to be another presenter today. We decided to share some of the content, so he will cover some parts. Okay, so as you can see, the destination port is also covered here, and then layer 7 is actually showing the HTTP data segments. It says that, hey, you ask for an HTTP GET request to /of/zytim.com, things like that. So these are the data segments. So as you can see, it's a pretty logical. And what hackers are doing, or what people are doing, that do I have to put really data segment in the data segment? Can I put something else? Because data segment is allowed you to put anything you want, okay? You're free to put anything you want. It doesn't hurt anybody. So Cisco decides to create a protocol for that. It's actually general routing encapsulation. We're going to come back to that in a minute. And it says that, hey, instead of putting a data segment as a data, I would like to put another IP and the TCP, UDP, and I mean layer 3, layer 4, and layer 7 data segments in the data segments. Is that fine? Of course it's fine. Instead of putting whole data here, they decided to put another IP header, another TCP header, another HTTP, and the data segment is going to be here. So the cost is actually, you have to spend your 20 bytes for IP segments, maybe 20 bytes for TCP, HTTP, TCP, and also another for HTTP. That's fine. We still can tolerate that because the data segment is actually approximately 1,000 bytes. Okay? So we have enough space to spend, let's say, 200 bytes. That's fine. That's why Cisco created a protocol called as general routing encapsulation, in which you can put another IP protocol. Let's see, MAC is layer 2, layer 3, another layer 3 package here, and saying that, hey, I would like to use a GRE protocol here, which means I can put another IP package and another layer 4, another data segments. So it actually, from GRE, I mean, from the IP to data is actually a data segment, but Cisco decides to use that in a different purpose. As you can see, here we have a source IP as a 10.0.0.1, and the destination is 10.0.0.2, and it says that this is the GRE protocol, and in GRE, another source IP, and as you can see, another IP package header here. It's from 1.1.1 to 2.2.2, okay? So it's possible, and the data segment is just right here. And when we look at in Wireshark, okay, let me open my GRE. Okay, yeah, let's clean up here. So Wireshark directly decodes the package and show you that, hey, it's a package from 1.1.2, 2.2.2 something, okay? But in fact, when you double click on that package, it says that, hey, in layer 1, I have this one, layer 2, I have this one, and let me collapse all of them. So as you can see, there is a layer 3 here, and it says that, hey, general routing encapsulation starts here, and inside general routing encapsulation, we have an ICMP protocol here, and this is the ICMP data segments, okay? This is how it works. So we can put another protocol, we can put a protocol to another protocol. That's perfectly fine. So, what's the matter? What's wrong with this?
I'm assuming that's GRE 2784 RFC versus we got 2 bytes right there that actually define that it wasn't 1701.
Yeah, that is possible because the RFC, the original RFC may be changed. I don't know. Maybe they decided to, yeah, because this GRE belonged to maybe in early 19, so that might be a little bit old, they may decide to use another version. So, okay, so what's the matter right here? So if somebody can put another IP segment in a data segment, I can put whatever I want, right? In theory, you can put whatever you want in the data segments. The only thing is the target should understand your package, right? So that's why if you have any package on here and the destination is here, you have to tell your destination that, hey, I'm sending a special package to you. When you open it, there will be another IP package. Please open that also. Okay? This is how VPN works. I actually puts your IP package in a different IP package. So the server is going to take the encapsulation protocol and send it to internet. So you can have an HTTP communication over ICMP. It is possible on DNS also, because we love DNS first of all, because it's built-in proxies on an enterprise network, right? How many people agree on that? DNS is an built-in proxy servers on an enterprise network. Is that true? Yes, because DNS have a recursive capability, right? You can resolve a DNS query with the recursive queries. So every DNS, you usually have a capability to resolve a DNS. And if I can subscribe a domain name that is running on my DNS server, right? The DNS server on the corporate network, let's say my domain name is jandan.com. If I ask at www.jandan.com, what's going to happen? It's going to ask the DNS server. DNS say, hey, I have no idea what www.jandan.com. Let me go to authoritative DNS server and ask him. My DNS server knows that if you see something like, let's say, www, resolve that IP, okay? Resolve that DNS server. But if you see something ABC, www, XYZ, that's actually a secret between you and me. And if you see, please base 64 decode it and send it to internet, bring me the result. Okay, this is what we can do in a DNS tunneling. We will see in a little bit details here, but this is how it works. And even we can create a malware which will communicate your local DNS server to resolve the domain names, and it's going to come back to our authoritative DNS server, and our authoritative DNS server may send the package to internet. On the internet, we may host our command and control center. We can use full DNS infrastructure to manage a malware. So we don't have any internet connection. As long as your machine can resolve a DNS package, that's fine. To be honest with you, in many organizations, we saw that DNS tunnel is a #1 vulnerability, and almost 95% I found that DNS tunnel is vulnerable on the network. So I will give my domain name to test your environment, but please, only testing purposes, okay? It will be available only 1 or 2 days. At the end of this week, then I will change the password, okay? So let's do a demo. Would you like to join us? Do you want to use your computer or you want to use my computer? Sure, go ahead. You don't have Wi-Fi? Actually, you can connect it. It's on the table. Do you need a couple of minutes to connect, or? Okay, let me see. I can pause this recording or not.
So I've got SSH and ICMP.
Okay, if you're ready, yeah, let's go ahead on that. So Fletcher would like to run the demo for us. And if you guys are interested in, hey, I would like to help you some parts of your meetup, please shoot me an email so we can split the contents. You can show your effort to the people.
In this video, we're going to go over SSH and ICMP tunneling. That just means taking regular internet traffic, IP traffic, and encapsulating it in another protocol like SSH or ICMP ping. This can be useful in a number of different scenarios when you might not have regular internet access, but other protocols like SSH or being able to ping are allowed. So in order to do this, we're going to use Amazon Web Services. So the first thing I'm going to do is launch an EC2 box. I don't have any running instances, so I'll hit Launch Instance and start a regular Ubuntu server. And this is going to be the server that I tunnel to, or tunnel through rather. You'll see this is free tier eligible for small boxes. So if you sign up for AWS, you'll get basically a year free of small resources. But even if you're not on the free year, it's pretty cheap if you're not using this too frequently. So I'm going to review and launch. It has a little warning about my security group. So I'm going to edit security groups here. And I'm going to use this box later for ping tunneling, so I'm going to also allow ICMP traffic from everywhere. Now, this does mean that anyone can ping your box, so possibly not the best security setup, but it may be required for what you want to do. For instance, if you want to keep this running and access it from some currently unknown computer later. You can always password protect to help with that. And I'm going to set up SSH access, and that will be just for my own IP. Review and launch. And I can go ahead and launch now. Let me create a new key pair. And I'll name this tunnels and download it. And launch my instance. Now I'm going to take this PEM file. Let me click on my instance and see it loading here. Pending, all right. I'm going to take this PEM file and load it into Kali, my VM. So I'm copying over my private key now, and let me go out to my Kali box. And I'm going to put this in my SSH folder in, we'll call it ec2.pem. If I just paste that in and write it out, I'm going to do one more thing in setting up SSH through this box. I'm going to set up a config file, and this will help make it a little easier without having really long lines when I'm SSHing in or running commands. So first I want the host, which will be that now running EC2's public IP. So I'll copy that in. And within that, I specify my default user, which is Ubuntu on an Ubuntu box. The host name, which is again, we can just use that IP. Default port, which is 22 for SSH. And my identity file, which is that file I just added and called EC2. I'll save that out. And that's about it. You don't need admin access on the box. We saw that it was running. And we don't even have to install anything on it so long as we can access it via SSH. So I'm going to use a program called Shuttle, S-Shuttle, Shuttle with an extra S. And in order to get it, all we have to do is pip install S-Shuttle. In this case, I already have on this box, so it'll be requirement satisfied. Oh, actually, one last thing we all have to do is we should change the permissions on that EC2 file. So now, and we can check, we only have root read permissions on that file to secure it. So now I can run S-Shuttle to connect. It has a really handy DNS flag, which means we're also doing DNS tunneling, so things like dig will also run through this tunnel. And I just point this at my Amazon IP again, and I can specify an IP address or mask that I want to route through it. In this case, I'll just route all my traffic through it. Yes, I trust myself. And it says client connected, so let's open up a browser and see how we did. I'm also going to capture this in Wireshark. So we do have an internet connection, and we can see that the traffic we're sending is actually all SSH traffic. One last test, let's see if the DNS flag worked. If I just open up a new terminal, let's dig for Google. And sure enough, that is also going through SSH back and forth from that Amazon IP. Let's move on to ping tunneling, ICMP tunneling. We're going to use a tool called Hans. There are a number of others, ping tunnel, ICMP-TX, ICMP tunnel. We're actually going to set it up on my local machine using macOS. But since we have SSH into that EC2 box set up already, let's start with that because we'll need to make a few modifications on that Amazon box. So first thing first, we need to update our packages. And then install a couple tools to help us compile Hans. And if I go out here and look for Hans tunnel, this is the main page for it. You can see that it has links to the source as well as binaries for Mac and Windows. Let's go out to the source here. I'm just going to copy this address. Actually, I'll copy this address. And we will wget that file. And then we're just going to unzip it and make it, compile it. If we take a look at what's in there, so far so good, make. And now we have that Hans executable here. And we can run it. So I'm going to specify a device. This TUN0 is a tunnel adapter. Just like you have a Wi-Fi or Ethernet adapter, we're creating this virtual tunnel. I'm also going to specify a password. Let's choose a strong password. Don't do that, actually. And we can see it opened and detached, so it should still be running. Let's take a quick look. And here's the process. Now we need to do a little configuration of IP tables so that we route traffic correctly. I should also say all of these commands are in a link in some notes in the description of this video, so you don't need to take down all of them directly from the video here. The first thing we're doing here is setting the maximum transmission unit size, essentially the size of packets allowed. And with these next few commands, what we're setting up is IP forwarding to allow essentially everything that reaches this EC2 box. It's going to send back out to the internet wherever it was heading to, stating it was heading to, once it unencapsulates these packets, acting as if they are its own requests. Oh, I might need sudo here. And when it receives responses back, it's going to forward those back through the tunnel. So with those commands, which again are in the linked notes, we should be all set. Now we're going to go out to my local computer. I would download this OSX binary. You could also compile it from source if you like. I already have it running. The other thing you'll need, there are a couple links here for drivers. TunTap is the name of this driver that you'll need in order to set up tunnels on your local machine. So let's go out to a terminal here. I've gone to the folder in which I have the Hans executable, and the last thing I'll need is the endpoint, public DNS endpoint. So I'm just going to copy that into my notepad and should be able to run Hans and connect to that server now. I'm going to specify that endpoint. Oops. Going to use the same password that I specified before and specify the virtual tunnel device. Open detaching should be running. Now the last thing you'll need is the IP command. For Mac, if you use brew, you can brew install IP root to Mac. And we're going to use the root command, so this will be IP root for Mac OS, and in Windows all you need is just root. Alright, so as soon as that completes, let's clear that out. And I'm going to modify my own root settings so that I'm sending all of my traffic over through that server instead. So first we copy over that same command that we did previously. We're going to take a look at what our current default is, and we're going to essentially replace this with a link to the tunnel. So I'm going to copy that public IP and that's going to be via this default. I'm going to delete the previous default and replace it. And this is the IP that I specified on the other side. So we should be all set. Let's open up Wireshark and take a look at our own traffic. I see a lot of ICMP traffic. Let's just reload a page. We can still get it reasonably fast. A whole lot of requests and replies, but nothing else besides some older TCP. And while we're at it, let's take a look at who I am. And it says my IP is the IP of that Amazon box. Now, the last thing you'll want to do is, of course, be able to revert that, turn that off and get your regular connection back. So in order to do that, I'm going to kill the Hans process. That was a bit aggressive. You might want to be careful if you have other similarly named things. And we're going to add our default back. If I just copy this over one more time, we should be back in business at home.
So as you guess, where you're gonna use a one DNS tunnel server and the other one is to be client. Of course, you can use the AWS, but my favorite is Google. This is just because actually I can use my machines on the browser. That's helped me a lot. So the thing is you are going to do is download and compile it, although it's not easy to compile, but I'm not going to go through every single detail. So assume that we have the iodine. Actually, let me change directory to iodine. So this is the source code when you download it. So all you need to do is make, then enter. So if you run it, it's going to create the iodine possibly, but unfortunately, as I said, there is a problem on the iodine server. But if you have a difficulty to compile, shoot me an email so I can help you to fix that problem. So, all right, so I already compiled this one and also the installed on my machine. So the only thing I need to do is iodine. Let me show you that. Iodine. Where is it? Okay, no, it's not working. Interesting. Let me see in my history. Oh, okay, probably it's in bin file. Let's change the directory to. Okay, there we go. So only iodine means that it's the client. Iodine with D at the end is the server. So the usage is easy. So when you type iodine daemon -help, it gives you a lot of help. Only needs is that you need to create a password with -p, and if you are interested in listening only IP version 4 or IP version 6, that's the problem. Code segment is IP version 6 is not working, so you have to put in a command line on that. So the only thing you need to do is with that password. So it's easy to run. It's let me check if it's still running on my background. PS and grab. Okay, so yeah, there we go. It's working. Actually, it's double working. I already started with something else. So let me kill them. Kill -9 and 1934. So I need to use sudo and 45. 35. Okay. So what I need to do is I would like to run this iodine daemon with a password and also the local IP address range. This local IP range has to be a different local IP segment that's in your machine. For example, in my machine, I would like to use in my callbacks. If I run ifconfig, I see that 172.16 network and also 10.0 network is used for my local network. If you're planning to use 10 network, you have to properly choose that because you mess up your route table, right? So that's why I would like to use 197, 198. That network, I never use it for any purpose. So it requires sudo because it has to create an tunnel interface. So if I run this, ifconfig, my tab is not working. Ifconfig, okay, I'm not sudo. Close. Okay, so when I run, as you can see, there is no tunnel interface, DNS interface. So what I like to do is I would like to run with sudo permission iodine. -4 means that use only the IP version 4, and -f means, I don't remember what's that. Let me see. It's not here. Anyway. And the -l double colon means IP version 6. If you are using that, it's going to be a loopback. And the capital P means the password. As you can see, I use my super complex password, so nobody can memorize that password. I will use this IP address as my server IP, and that domain name is the key one. So in order to run the DNS tunnel, you have to have a domain name that is managed by you, okay? You can't use anybody's domain name as a DNS tunnel. You have to have that domain name. And second, that domain name should have a name server pointing to this box, okay? So I registered this akyazılım.com and GoDaddy and tell that, hey, GoDaddy, the DNS server of this domain is this box, okay? You have to create that name server resource for that in order to work this properly in an external network. So let me run this. Okay, it's already running, listening the interface. So it's ready. What I need to do is in my callbox, I need to run to connect to this box, right? So for this moment, let me see if I have installed Okay, so you can assume that you download and compile it and make an install in this box. So there are a lot of helps to do that. So what I'm gonna do is iodine is the same command. If you run with help, it also gives you the same details here. The easiest way to run is iodine, please run with my domain name akyazilim.com. Okay, this is the easiest one. When you hit enter, it will ask you a password. So before putting my password, I would like to show you something that when I run my ifconfig, there are only two Ethernet interface and one loopback, right? Nothing else. So when I run with my password that I defined in the server side, it's going to connect to akyazilim.com. As you can see, it says that you are number 0 user, means that the first user, and it says that I have able to connect to the 192.168.0.1 IP address, means that I have successfully resolved these domain names. It's pointing the name server to that public IP address, and I saw that there is a DNS iodine server is running, and its IP address is 192.168.0.1. So it's going to be my gateway. And also there are interesting thing in iodine. Since DNS traffic is interesting, and it's not necessarily have to be a long bandwidth, right? In many cases, the DNS traffic is limited. So it's usually have more than, less than 500 bytes in a DNS package. That's why it optimizes that. As you can see, it tries with 700 something, and it sees that, hey, it's okay, let's try a bigger one. It tries with a 1000 something. Oh, it's not working. Let's try a smaller one, bigger one, smaller, bigger, and finally decides that, hey, the sizes DNS is, as you can see, 1078 bytes. So in this network, we can send the DNS package with this size. It's a perfect size. In many cases, in your organization, if you try, probably you will get something less than 300 bytes. So it's a good one for this one. In airports and hotels, it's usually less than 500. And in a plane, it's less than 200 bytes. So it's a really slow internet connection if you try to DNS tunnel in a plane. So I tried that. So that the DNS tunnel is working, but bandwidth is too slow to communicate. But at least you can use your SSH. It still works. Perfect. So what we're going to do, we have a DNS tunnel interface. So let's run this command again, and let's see. We have another interface. On top here, we have DNS tunnel interface 0. It has an IP address 192.168.0.2. Perfect. And when I check my root table, that's that minus NR. It says that, hey, your default gateway is 172.16.52.2. Means that there is a tunnel available, but I'm not using that, right? So when I check my IP address, this is the lightest site that you can check your IP address without spending a lot of bandwidth. So when I hit refresh here, as you can see, 98 something is the public IP address of here. So what we're gonna do, we will need to change our route table. How we can do? Okay, that is the command. So you need to delete your default gateway, and you have to put the new domain, new IP address that is at the other end of the tunnel. Okay, so at this stage, you have to be carefully check your IP address, because this is going to mess up your route table. Okay. So I messed up my route table a lot of times, so I give you an experience. So it says that I'm going to communicate with DNS tunnel interface for default gateway, and I see that 10.0.1.1 is responsible for the Ethernet 1, and it's going to be only responsibility of 10 networks. Okay, so perfect. Where is my DNS server, by the way? Where I'm communicating? Where is the local DNS server? It's right here, right? Cat etc resolve.conf. It is 172.16.52.2. Can I communicate with that IP address? With this route table? Why not? I have an Ethernet 0. It has an IP address 172.16 52.203. It's actually a layer 2 communication, right? So my DNS server is in my network. If it is in a different network, you have to carefully put that in a root record. That should say that wherever you want to go, you can go with tunnel 0, but you have to go from this interface to the DNS server, okay? It's a little bit different, configuration. Let me quickly show that actually. For example, here, I put a root to this table. Let's assume that my DNS server is 46 something, okay? If it's 46 something, I'm adding a rule saying that 46 something, go to use your own gateway, whatever it is. But otherwise, use my DNS tunnel interface. In this case, the tunnel interface is 10.100, okay? So this might be a little bit tricky if you're running in a network that's a different DNS network. So I have my root table. It's perfectly fine. When I refresh this page, I have the public IP address of my DNS server. So let's check it out with Wireshark. Where's Wireshark? There we go. So if I sniff my DNS tunnel 0, what kind of traffic am I gonna see? DNS 0. Am I going to see DNS traffic on DNS 0 interface or regular traffic? How many people saying the regular traffic? You're gonna see HTTP if I refresh the page. How many people? How many people say that you are going to see a DNS traffic? Okay. So this interface is actually a normal interface. So when I refresh this page, I will see an HTTP traffic on this interface. But when I actually capture my real interface, which is Ethernet 0, is the physical interface. Okay, let's cancel it. And if I refresh this page, as you can see, there is only DNS traffic. And when you look at this DNS package, actually, it's pretty interesting. A null record, and it has a lot of garbage at the end. So it's a little big, DNS package. It's not usual, and it carries some data which includes HTTP traffic. Does that make sense? Are we happy with that? So we have another stage. So this is DNS tunnel, but somebody must run a DNS tunnel from the inside the network, right? In this case, let's assume that you're trying to run an advanced persistent threat penetration testing, APT testing for a company. Actually, we did it before. And there were no internet connection on the client network, but they can resolve the DNS. That's what we discovered. But the thing is, I don't have any malware that communicates over the DNS, right? And every single session that we are talking about, we created a meterpreter that communicates with the internet directly, right? In this case, we don't have any. So luckily, there is an open source, and also we have the modified version of that. But DNS Chan, let me find it. DNS Chan, DNS channel, DNS Chan maybe. Tunnel. That's interesting. What's that? DNS. What is the name? DNS Chum. Okay, maybe it's from GitHub. Oh, I couldn't find it, but okay. Anyway, I will find, but unfortunately, I didn't record the URL, so maybe it's somewhere else. But I will definitely find it and put it in the on the meetup page. So this guy has a capability to communicate over the DNS. So basically, when you download this, it has a package.cpp. It's a C++ application. What you need to do is you need to put the domain name that you would like to use for the DNS tunnel enabled malware. So the server side should also use the same domain name to communicate with each other. I think you got the idea already. So in this testing purposes, I will use test.candan.intra. It's a local domain, and I have a DNS server right here, just like your enterprise network DNS server. So what I'm going to do is I would like to add an forwarder here. You don't have to put your forwarder in your DNS server because you already have a domain name that's already forwarding to internet, right? But in this case, I'm going to use a local DNS, local domain name. It has no relevant record on the internet, so that's why I'm putting the domain name that belongs to me. So DNS name. So 10.0.1.101 is going to be my DNS server IP address, and that is my callbacks. Let me see. Oh, okay. Let's change back to our root table. So I have a command for that also. So if you would like to test the DNS tunnel in your network, you already have the domain name. What you need to do is iodine and domain name it's akkiyazılım.com, and the password is, you already have that password. P is capital, O is 0. So if you compile an iodine on a Kali box or on a Linux box or your OS X machine, you can test it out in your network. If you would like me to test, shoot me an email. Okay, so let's change my root table, and let's DNS 0 or 1 or 2, DNS 0 to down. Okay, perfect. So I have an IP address 10.0.1.101 is going to be my DNS server. So what I'm going to do is I would like to change to directory. Where am I now? Okay. Tunneling. Okay. Okay. So it has both server and client and the source code. I can share the source code if you want. When I change to the DNS server folder, there are two files. One is one Ruby file. The other one is the main.ruby. Main.ruby is responsible for running the server, but the trick is in the server file. So let's take a look at with the DNS server.rb. So what you need to do is you need to change the domain name that is responsible for you. So it says that in the change the @domain name in the file, then change the command on the line 286, and also in the client file, as I mentioned in the package.cpp, you have to change the same domain name in that file also. That's all you need to do, then you're ready to go. It's a Ruby file. If you have a Ruby installed on your box, you can quickly run that. So for example, here I will run it main.rb. It already has the domain name in the file and ready to go. So when I hit enter, it says there's nothing here. When I hit I, it actually shows the clients connected to this command and control center. There's nothing here, and let me run this one. For example, if I run with Control F5, it's going to compile and run the DNS client. Let me check my tasks. As you can see, there is a DNS client is running now. When I jump back to my command and control center, I see that new client is connected to here. When I sniff with my Wireshark, let's see options, and let's start to, it's actually in Ethernet 1. Okay, yeah. Cancel. So as you can see, test.candan.intra having a couple of records. It's you see that there is a pattern in this one, and it's actually trying to send a heartbeat to the command and control center saying that, hey, I'm here, do you want me to do anything? Yes, I want you to do something. So let me see which folder I am. Okay, when I hit the command line, it shows me that you are under Z/Candan documents development somewhere. Okay, so I even can run fconfig here. So it's actually a command line, but it's running over DNS. So I can communicate over DNS with my command and control center, and this box has actually no internet connection. Let me quickly show that. So for example, if I try to ping to 8.8.8.8, there is no internet connection, but it can communicate with over DNS. So I can do whatever I want. For example, I can get ifconfig, but I definitely can run another command. For example, by the way, it's not ifconfig, it has to be ipconfig. So let's run something funny. Let's run a basic exploit like calculator or notepad. Let's wait for the output for this command. Come on. As you can see in DNS, it takes time, okay? You have to be patient for that. So let me quickly show that. As you can see on the screen, there is no notepad, right? Okay. So let's run notepad here. .exe. There we go. We have a notepad here, and I can run a calculator here, though. What is the command name? Calc.exe. Has to be a calc. Anyway, so maybe you can try to be persistent. For example, here you can see that it can be persistent, can copy itself to a startup folder, or even you can create a scheduled task for that, because especially if you're running over a tunnel interface, you have to find a way to be persistent on that machine, because somebody may cause a network distraction, your connection may die, so you shouldn't send another phishing email to your target and, hey, I just lost my connection, can you click on this link also? Yeah, it doesn't work. So this is how you can communicate over a DNS without any IP protocol, without any other IP protocol. So are we happy? Is it fine? So you can say die, and capital letter die kills the communication. I hope it's going to kill. Anyway, so this is how we can use a DNS tunnel interface. And lastly, I would like to show you the promiscuous mode tunneling, and I will let you go. So we already covered this one. So custom Tor configuration, yeah, this is an interesting and easy one to configure. So if you have any Linux box, okay, you can configure a Tor and actually apt.get space install space Tor. I sometimes switch back to Turkish. So install, this command is going to help you to install a Tor daemon on this box, okay? But the default is Tor is running on 9050, right? 9150. It's a very famous port. So any network blocks the Tor networks because that port is pretty well known. But you can change the configuration in the Tor, so you can let it to listen on 443. For example, in this one, net that minus okay. So my Tor is actually listening port 443. So I can easily use it as a SOX proxy to connect to internet. The biggest, advantage of using 443, it's pretty much allowed in most networks, and it's not sniffed pretty much, yeah, right? Because 443 is an encrypted protocol. There are very few companies are SL decrypting, so it will help you to tunnel over an IP or a firewall. For example, in this box, I have let me switch back to my original proxy configuration. So in default, if I check my Tor configuration, it says that you are not connected to Tor and your IP address is 97.191 something, okay? But if I configure let me show you first of all. So this is my Tor network, Tor configuration. As you can see, it's a SOX proxy. SOX proxy means it operates on layer 4. So it will forward my traffic to this IP address, to this port. I assume that it's allowed. So I have a perfect chance to access to both Tor and normal internet with 443, even if it's blocked. So let me connect to to my Tor nodes. Now I'm connected to Tor. I can easily access, and if I check my IP address, org, What the hell? 46. Okay, it's connected to Tor. Okay, that's why. So, okay, I have a different IP address because Tor also has a lot of, the proxies in itself. That's why I'm not seeing my public IP address. Instead, I'm seeing an exit Tor node IP address. This is how Tor operates. Set up a Tor, change the listening port, then you are good to go. Yep. Mm-hmm. Mm-hmm. Tor is actually a standalone application that only listens a port, which is in this case is a 443. So you're forwarding your package to that port with a SOX proxy protocol definition. So that's all the trick. So that's easy. And the best part is you don't need any client installation in this case. Just only change the proxy configuration of your browser. You're good to go. Okay. So if you guys interested in, I'm not going to cover this part, but there is a special Linux distribution available on the internet, which is Hunix. How many people heard that before? Hunix. That's a really good one. I really love this. But this actually acts like a gateway. So in many cases, if you would like to forward the traffic to, let's say, Tor network, the application must be a proxy aware, right? For example, you can forward a browser to a SOX proxy, but you can't forward a terminal service to a proxy, right? In Microsoft Windows, the RDP application is not proxy aware. There is no way to forward the RDP protocol to a proxy with the default setup. So what you need to do is just download this box. It's a virtual machine set up in a virtual environment. Just change the gateway of your Windows machine to this box. You're in Tor. All your application is going to be in the Tor network. So that is the easiest and safest way to be anonymized. But this course is not only focused on anonymizing, but this time we are going to tunnel. So the last thing we're going to show is the promiscuous mode tunnel. What's this? So in normal mode, your network I/O buffer is something like this. You have a network interface card. On top of that, the OS running OS programs, code segments, and OS is running the driver. And the driver, on top of the driver, there is a firewall. It's actually a personal firewall. It's not an enterprise firewall. So, and after a firewall, the applications can communicate with the firewall. Hey, firewall, could you let me my package to go in my network or go in my application buffer? So this is how it works. But the thing is, if you run an application in a promiscuous mode, it's running on the firewall. It's directly communicates with the driver's I/O buffer, so it will help to carry a package even if it's not allowed in the firewall, right? Did you get the idea? Because the application, it's a promiscuous mode enabled application, is running under the firewall. It's directly communicating with network I/O buffer, so it can capture any package from the I/O buffer, although firewall decides to block it. Okay. This is the idea under the promiscuous mode tunneling. So let me show you an example for that. So let me come back to my Kali box again and give me a port number. Throw a port number. 25? Just choose a bigger one. 25. Okay. So let me take a look at it. Natstat minus NLTP and grab this port. Nothing is listened on this port, right? And if I send any package to this port, let me see that. Okay, the IP address is 172.16.52.203 in my Kali box. If I send 2525 port, it says I send the SYN package and I get, let me stop this, I get a flag with RA, which means reset and ACK. Means that the port is closed. So let's try again. Let's try again and let's take a look at with Wireshark here. Okay, it's already capturing. I hope it's capturing my interface. No, it's somewhere else. So capture options, the internet is going to be internet 0 in this case. Okay, so as you can see, TCP 2525 is coming here, and my machine is replying back to, hey, reset I have no port listening on this, because my netstat table is also saying that there is no application is listening on 2525. And you can see the whole list. So what can I do? I still can transfer some data on this port. So what I need to do is I need to run a promiscuous mode script. This is private up to now, but I will release it in a, let's say in a Black Hat or in a DEF CON. I don't know, just keeping it a secret now. So, but I would like to share it with you if you're interested in. When I run this, and I still can check, oops, just stop this one for a second. Okay, so it's running, and when I check my netstat table, it's not listening anything, right? Oh, pardon. There's no 2525, right? But this one is actually a promiscuous capability. So let me stop my Wireshark. Because I'm stopping this, if you run two promiscuous mode enabled applications together, you are going to get a problem. Wireshark itself is also a promiscuous mode enabled application, right? Because it can also grab the reset ACK packages, right? Although it's closed. So since Wireshark can do that, why not we did? Why not we are not doing that? So what I'm going to do is I will use hashping, hping, whatever you call, and I would like to transfer some data by using -d segment, okay? -d means the data length is going to be 50 bytes, and -e read the content from a file which is jandan.txt, and let me quickly show the content of that file, jandan.txt. It's written here. This meetup is fun. I learned a lot. Sorry about my English. I wish I can speak better than this, okay? So, okay, let me run with 2525 port. Okay, I still get reset ACK. There is no port open here, but in my Kali box, I can see that the data is actually transferred to my server side. As you can see, there are some garbages, but I can easily understand that my data is transferred over a closed port, although as you can see in my netstat table, there is no port listening that. So in this course, we learned something that if a port is open, then I can use that port to leverage to access to any port, any IP, any domain, any application, any IP protocol. That's fine. And if it's, let's say, and there is no port open, but we can resolve a DNS packages, there is a way to access to internet, even it's slow, but there's still a chance to do that. And if there is an open port, let's say 443, which is an encrypted port, we can use it as a SOX proxy, so we can take advantage of being not decrypted on that port. And if you are in a local network, if you have a chance to run a promiscuous mode, you don't need any protocol, you don't need any port to be open. You can use any port to transfer any traffic. It's just up to you. So I think that's all I would like to share with you today. Any question? Any comments? Any suggestions? Okay, perfect. So, yep. Oh, yes, I heard that. Actually, somebody in Black Hat, yep, did something like that. And yeah, I heard that before. And actually, interesting thing is somebody is also mentioning an HTML tunneling. Oh, that's an interesting one. I would like to see that. But yeah, if there is a protocol definition, we can put anything we want. So we can use that any purpose. Thank you for listening, me guys. I'll see you in the next meetup. I will announce the next meetup probably tomorrow in the meetup page, and we will start with incident response and forensic analysis in the next, not the one, but the other one. We will start with the new content. Okay, have a wonderful night. Goodbye.